Alright, welcome to the C Makefile tutorial 102. What we're going to be doing in this tutorial is creating a makefile to call other makefiles in subdirectories of the parent directory. We're just going to create a simple program that calls two functions from an archive file, and we're going to review some of the GCC compiler options, find out where to find information using the Linux command terminal. So let's get started. I'm using VS Code for my text editor, which is an upgrade from the Vim editor we used in the example 101. If you have not watched example 101, you can find it here. It's called C Makefile Tutorial 101, or you can just search for my tag name, Programmer 3591, and that'll drop you in. You can find all the videos there. I will create a CMake tutorial playlist. You can just start from there. If you're interested in like how Visual Studio Code works, you can also install that via the command line. Just watch my other video, also under Programmer 3591, called Install VS Code via Linux Ubuntu, yada yada yada. All right, so let's get started. First thing we're going to need to do is make a project file. So we're going to start with make drive and make file example 102. And then we're going to create two nested directories in there. Make file example 102 /. We're going to make our program directory, and we're also going to make our library directory. All right, change directory into it. Or I'm just going to open a VS Code. So the N option means open in a new window, and specify the folder that we want to open, and that'll open VS Code. There we go. We have our makefile example 102. We have our library and our program. First thing we need to do, let's start with the library. We're going to create a new file within the library subdirectory called famous quote 1.c. Famous quote 1.c. I'm going to just go ahead and copy and paste the text. And save it. All we need is the standard input-output header, because we're using fprintf, and we're using the call to the standard out. And there's our famous quote from Christian Lewis Lang. All right, that's famous quote 1. And then we're going to create another file called famous quote 2.c. And our second famous quote of the day. So we have a subroutine, famous quote 2, fprintf, std out. Quality is never an accident. It is always the result of intelligent effort, by John Ruskin. And we're going to save that. So we have famous quote 1 function and famous quote 2 function defined. Now, as for the program, we're going to create a new file under program, and we're going to name that. What are we going to name that? We're going to name that, easy enough, famous quote prog.c. All right, so we're going to create our main entry point for the program. You include stdio.h. And, you know, we might not even need that. Why don't we just get rid of that for the moment? Let's see if that works. All right, so we have int main. All right, we are externally linking famous quote 1 from one of the dependencies and famous quote 2 from another dependency. And then we are calling both of those functions, and then we're closing the program. All right, so now let us add. We'll start with the lib folder. Go ahead and make file inside of lib folder. All right, for the lib make folder, we're going to add some code here. And to start off, we're creating macros, user-defined macros, objects, and we took the name of the file and appended O instead of C, or replaced C with O. That is the output file name of famous quote 1 and famous quote 2. And then we are creating a lib1 macro, and that name should be fq capital lib dot a as an archive file. Then we're going to create our other two macros. So that is our compiler flags and access to our compiler. Now, here is the rest of the code. So here we have the all target. So when we run make all, it runs this code here. What is dependent on building all? It is the objects. So we need the output files to exist. Then we have AR space RV, and then we have the name of the output file, which is fqlib.a. So that is going to be what is created and the name. And then at the end, we have the dependencies to build the archive file. And then the .c.o, that is defined behind the scenes. We're specifically defining it here. And what this says is the money sign less than sign is the name of .c. So every C file within the directory is going to be run, and it will output the C file as an object file. And that is what the compiler does. So we don't need any more instructions to tell it what to do. This is shorthand. We could write it out a different way, and if you're interested, I would look up the make files of the GCC compiler. Now, a quick way to examine some of the options you have on certain Linux commands that are usually highly supported. We would run man cc. So that opens the manual here, and it tells you it is the GCC GNU Project C and C++ compiler. So when you invoke it, it normally does pre-processing, compilation, assembly, and linking. The overall options allow you to stop this process. Yada, yada, yada. All right, so moving on, we are looking specifically for our call here, which is C flags. So we are taking the option of C. So if we page down till we see the -C option, yeah, which is right there. So I have -C. It says, compile or assemble the source code, but do not link. The linking stage simply is not done. The ultimate output is in a form of an object file for each source file. Source file being C, object file being the output file. So that's what that means. So we are building these two output files, by searching the directory for every C file and building the output file. We know right here what the output file names are going to be because they directly relate to the actual file name itself. So we're just, go ahead and specify that right off the bat, and then we can say, what are the requirements for all. Well, the requirements for all is to have the object files. So the processor, GNU or GCC processor knows when it hits a C file, how to output it as an object file. Now, the ARRV, what does that do? So we'll type Q to quit, then man, and we'll go AR. If we look down for the, okay, so AR is to create, modify, or extract from archives. So basically what we are doing, we are condensing both of these files into a single archive file. An archive is a single file holding a collection of other files in a structure that makes it possible to retrieve the original individual files called members of the archive. If we move down, we are looking for the R option. DQ, there's R. All right, insert the files to the archive with replacement. This operation differs from Q in that any previous existing members are deleted if their names match those being added. All right, so this also has deleted versus replacement. You would probably have to test that and make sure that the new object files are in fact replacing and not deleting based on the command being run again. And the lowercase v after, you can find that down here. The modifier v is used with this operation, elicts a line of output for each file insert. All right, so it's just verbatim. It says, what are you doing? Print it out the screen. So we are inserting the files or replacing the files into the archive. All right, so that is AR, and then, oh wait, hold on. Let me just check that one more time. Okay, yes, AR is the name archive. So that is not two commands there, that is a single command. And then we have R, insert, and then V, which is defined down here, lowercase v, verbose version of an operation. All right, so here we are building our archive file, and it's going to be output as this. And then you have your clean action, which is remove, force recursive, your library one, which is the archive, and your objects. All right, so now go into program and make a new file called Makefile for building the program. All right, so what we can do there is Makefile for famous quote program.c. We're going to name the program, that's going to be the executable, famous quote program. We have the program object files, which there's only one, that is the famous quote program object file. And then the location of the library, the library archive we had just created, which we defined its name here, and its name is then used here as the output file name that we just went over. So you double dot, backs you out of program, puts you back in make file example 102, lib, you go into that file, and then find the location of fqlib.a. And then next, we will need some more macros here. And we can use cc equals c, and then ld for linker. We're also going to call cc. And then CF flags, it's going to be the same, which was do not link, just produce the output file, right? And then we can place this here, which is, whoops, LD flags, so the linker flags, and there's nothing in the linker flags. We are just leaving that empty. We're just placing it there for readability, and if you ever need to edit this, you just change what you need there instead of changing it down here. All right, so what this says is program is the target. So program, what does program depend on? Program depends on the program object file and the lib file. So what are we doing here? We are linking, no linking flags. Output file name is the name of the program, which will be the executable file quote program and the dependencies thereafter. Remember there's a tab here. So this is our target. So when this runs, it's going to go program. What does program find its dependencies? Do we have everything we need to build the executable? Yes, we do. It's going to link both of these to program, or link both of these together and then produce program. All right, and then we have our standard explicit declaration of how to convert C files to object files. And then also we have our clean, which we will show how that is used here momentarily. All right, so we save everything. This has not been saved. We'll save that one. And our last Makefile goes in the parent directory of both of these subdirectories. So I'm going to create a new file, and that's called Makefile. One more time. We're just going to call this the Makefile master for famous quote program. All right. Now here we have another macro. We're calling it subdirectory 1, which is lib. So if you have different subdirectory names, you're going to create one for each of these. So one is lib and one is prog. We give it its own macro. And then when we run make all, what are the dependencies? The dependencies are that these exist. These subdirectories exist. And then we say change directory into subdirectory 1, and then make. Don't forget the tab here. This is an actual command that's going to run and not just be parsed. So this is tab command under the actual action or target. So you have target and dependencies here. So we're going to change into lib directory. Now it's important to build the archive before we try to link the actual executable together. So that's what we're doing here. At first we're running the lib archive makefile, and then second we are building the actual program, and below on clean we are going into the subdirectory and we're just running the make clean with however and whatever we defined inside the clean action with those individual files. So there is a clear separation of concerns here. Each makefile does what it's supposed to, and just the upper makefile will, or the parent makefile will just call a specific action. All right, so if everything is set up correctly, we should be able to locate that directory, makefile 2. There it is. If we list program. We can see that and list the library. We can see that. So we have all the files we just made, and we are going to run make in the parent directory once. And this walks through. It says it is entering the library. It is taking every C file and outputting an object file, C file, object file. Then it is creating the fqlib using the dependencies it just created, which is famous quote 1.0 and famous quote 2.0. Boom, it created it, added that to it, and then that to it. So our archive has been successfully created. Then we leave the directory, we change to the program directory, we enter that directory, we find any C files and we output them as object files. And then the linker, we exclude the -c, which explicitly says do not run the linker because we just need the object files. We're not ready to link everything together. However, we omit that, and here we define the output file. So that is going to be the name of the executable, famous quote program. And then when we have the dependencies thereafter, which is the famous quote program.o, and then the single archive file, which actually contains two object files, and we link those together. So now, when we look into program, we will see our famous quote program. And same for when we look into library, we can see we have our fq library.a archive file. So to run this program, we do period /prog /. I hit tab, it finds it, it's the only executable, it knows this is an executable command. Hit enter, and there we go. Technology is a useful servant, but a dangerous master by Chris Lewis Lang. And then quality is never an accident. It is always the result of intelligent effort by John Ruskin. All right, so that sums it up for the second tutorial in C Makefiles. Thanks for watching. If you like, please hit the like button and subscribe. Hopefully